Welcome to Homework Lib.
The angle of inclination of AC can be found by thinking of x equals 3, which is parallel to the x-axis, excuse me, y equals 3, which is parallel to the x-axis, and we could find this angle here by considering a right triangle, and then this would be a length of 3 and a length of 2, and you could do tangent. So you could do tangent of the angle, which would be here, equals opposite over adjacent. So it's the inverse tangent of 2/3. In a calculator, degree mode, inverse tangent of 2/3 is 33.69 degrees. To the nearest tenth of a degree, we'll say 33.7. Or 180 minus that would be another condition, like 146.3, depending on what you're used to doing. Okay, then we want to calculate the angle between AC and BC to the nearest tenth of a degree. Well, the length of AC, by using the Pythagorean theorem or the distance formula, would be the square root of the difference between your x's, which is 3 squared, plus the difference between your y coordinates, which is 2 squared, or 9 plus 4 is 13. So it's the square root of 13 exactly. BC is the square root of the difference between the x coordinates is 2 squared, plus the difference between the y coordinates is 4 squared, or 4 plus 16, which is 20 exactly. And we might as well do AB as well. Its distance or length would be the square root of the difference between the x coordinates, which is 5 units, plus the difference between the y coordinates, which is 2. So that's 25 plus 4, or 29, the square root of 29 exactly. So we can find the angle between AC and BC using the law of cosines would be an approach. I'm going to call it angle C, but opposite angle C is the 29, square root of 29. So it's the square root of 29 squared by the law of cosines is equal to the other two sides squared, their sum, minus 2 times their product, times the cosine of the included angle, which is what we want to find. So what we'll do is subtract the square root of 13. Well, let me actually clean this up, because we can make this a little bit easier on ourselves. The square root of 29 squared is 29. The square root of 13 squared is 13. The square root of 20 squared is 20. So we'll start with 29, and we'll subtract 13 and 20, and we get -4. Then we will divide by -2 times the square root of 13 times the square root of 20, and that will equal cosine C. So angle C would be the inverse cosine. Make sure you are in degree mode, and the inverse cosine of -4 over -2 times the square root of 13 times the square root of 20 to the nearest tenth would be 82.9 degrees. The area of the triangle, now that we know that this is 82.9 degrees, can be found using the formula area equals 1/2 times, we want the included angle on the sides next to it, so square root of 13 times the square root of 20 times the sine of that included angle, 82.9 degrees. So 1/2 times the square root of 13 times the square root of 20 times the sine of 82.9 degrees is 8. That would be 8 square units.